Welcome back after the break, and let's continue looking at the conditions necessary for the formation of a tropical cyclone. Now, the first thing that we looked at the ocean temperatures. We need the ocean temperature above 27 degrees Celsius because, like I've mentioned, it's the fuel for this tropical cyclone. Now, the second thing is very importantly, because of this warm ocean temperatures, we've got strong convection currents moving upwards, creating this low pressure system. Now, remember, the low pressure system is rising air. Now, keep in mind, this low pressure system develops over the ocean. Now, when we experience warm conditions over the ocean, what happens? Evaporation. Evaporation is when the water turns back into a liquid. Eventually, the air will rise, and the water will turn into a gas. I apologize. And eventually, as this gas rises, it will cool down and it will condense. When this condensation takes place, we experience latent heat being released. Now, this also adds to the fuel for this tropical cyclone. It strengthens this updraft that's being created. Now, obviously, when we look at a low pressure system, it's usually unstable air because it's rising air. And very importantly, now, when a tropical cyclone, the initial stage, when it starts to form, it needs to be perfect conditions. Warm ocean temperatures, high humidity. And very importantly, it needs to be a friction-free surface. What does friction-free means? It means it needs to be a smooth surface for this tropical cyclone to form. There mustn't be any disturbances. Just to explain friction to you, let's say for instance, as wind moves from a high pressure to a low pressure and it blows over a city like Johannesburg, is it going to be friction free? No. Why not? Because there's many buildings in the way. Now, a friction free surface, if there's no obstacles in its way. So these conditions need to persist for a couple of days for this tropical cyclone to develop. Now, as you can see, there needs to be little surface friction, like I've mentioned before. Well, this one jumped. And there needs to be low atmospheric pressure in general. Okay. Now, very important, tropical cyclones can't form if there's anticyclonic conditions. Now, anticyclonic conditions is high pressure systems. This we will discuss in detail in the next episode. But let's continue with tropical cyclones. Now, just quickly recap conditions for the formation. As you can see, can only form 5 degrees from the equator because it needs that Coriolis force. Now, there's divergence in the upper atmosphere. Very importantly, we're going to have a look at it now in the next couple of minutes. And the conditions, like I've mentioned, we need this warm ocean currents, warm ocean temperatures, high humidity, and latent heat. We need these conditions and friction-free surfaces for a couple of days for the formation taking place. Now, if you look at the mature stage of a tropical cyclone, this is a cross-section through a tropical cyclone. We've already established what's very important is rising air, as you can see over there. It's rising air. Why do we experience rising air? Because of the warm ocean temperatures, the high humidity. So what happens if it's rising air? It cools, condenses clouds. Okay, let's stop at the clouds. And as you can see, we get this massive cumulonimbus clouds formation taking place. Now, obviously, these clouds will lead eventually to rain. And as the air rises, divergences are taking place, moving away from each other, and eventually it will lead to the eye of the tropical cyclone, where it's subsiding air. Subsiding means sinking air. Now, very importantly, that is a cross-sectional point of view of a tropical cyclone. It's very easy to identify a tropical cyclone on a synoptic point of view. It's perfectly shaped around isobars. The isobars are very close to one another. Now, in the previous lesson, we looked at isobars when we look at synoptic charts. When isobars are far from one another, what did we say? It's a gentle wind. When isobars are very close to one another, it's very strong winds. And to be able to identify it, the pressure will be below 1,000 hectopascal. Now, the same as weather stations, we actually use a symbol for a tropical cyclone, and that's the I. And like I've mentioned, perfectly shaped round isobars, and the system moves in the westerly wind belt. Now, the I that you see over there, if we just go back up, that's where the subsidence is sinking. And around the eye, this area over here is known as the eye wall. That's where we experience the worst weather because of the strong convection, uprising of air. Now, as you can see, there you go, a synoptic view of a tropical cyclone, the one that's the same example that's in your textbook. Very importantly, this tropical cyclone is in the southern hemisphere because it moves in a clockwise circulation. There's the eye. I'm just going to draw it in there for you. And as you can see, the isobars are very close together, meaning very strong winds. Now, very importantly, once we get to the mature stage of a tropical cyclone, I'm going to quickly draw to you Now, like I've mentioned to you, let's just quickly have a look at it. Tropical cyclones develop from 5 degrees. Let's say, let's quickly draw Africa again over here. There's Madagascar. From up here, the initial stage where it develops over the warm tropical oceans to the mature stage. Now we know it travels from east to west in the easterly wind belt, and then eventually it will move further away. Right, east to west in the westerly wind belt, and eventually in the easterly wind belt away. Very importantly, the stage that we're going to discuss now is the mature stage. The mature stage is when a tropical cyclone is well developed. Now, when it's well developed, we actually give them a name. Now, this year alone, in 2016, we've experienced numerous tropical cyclones all around the world. Now, if you look at the tropical cyclones, as soon as it reaches its mature stage, meteorologists give the tropical cyclone a name. Now, tropical cyclones are named according to alphabetical order. There's the I to identify it on the synoptic chart, and on the synoptic chart, they will tell you it is tropical cyclone Edward. Now, Edward, tropical cyclone Edward will be the A, B, C, D, E. Edward will be the 5th cyclone for the season. Now, for instance, in 2017, we experienced Hurricane Harvey and Hurricane Irma. Now, very importantly that you need to remember over here. Remember, tropical cyclones is exactly the same thing as a hurricane. Where do we call them hurricanes? In America. Now, how many cyclones was there before tropical Hurricane Harvey? A, B, C, D, E, F, G, H. So that means there were 7 tropical cyclones or hurricanes before Hurricane Harvey. Very importantly, so we refer to them and we name them to alphabetically. Now, very importantly, how to identify the mature stage of a tropical cyclone. The pressure will be well below 1,000 hectopascal, as you can see. So this over here is definitely the mature stage. And let's give it a name. Let's call it Tropical Cyclone Bongani. Now, what does that mean? Works with the letters of the alphabet, A, B, so that means Bongani, Tropical Cyclone Bongani, will be the second tropical cyclone for the year. As you can see, very strong winds, up to 120 to 180 kilometers per hour. How can we see it? Because the isobars are very close to one another. Importantly, the pressure is well below 1,000 hectopascal. Now, as the system moves from east to west, there's the initial stage, and as the system moves in the westerly wind belt, very importantly, the southwestern quadrant, this area over here, will experience the worst weather. The reason why is because the isobars are being forced together. And as you know by now, if the isobars are closer to one another, we experience worse weather conditions. Now, a couple of more characteristics about the mature stage of a tropical cyclone. The highest wind speeds is closest to the eye wall. If we go to the cross section in the previous couple of slides, we had your first vortex and your second vortex. Your worst weather is being experienced in this area over here. The system has a fully developed eye. The eye, just to recap, is where the subsidence are taking place, sinking air. It's cloudless, clear blue skies. Cumulonimbus clouds, rains and thunderstorms goes apart with it. Like I've mentioned on the previous slide, the southwestern area of the tropical cyclone, this area over here, experienced the worst weather because it's moving into that direction. So these isobars are being pushed towards one another. Now, when we look at the characteristics as we follow over here, we can see that it's a very fierce storm during its mature stage. Now, Gr12, we had the opportunity to experience tropical cyclones firsthand in South Africa in 2017. During March, we experienced the Neo. Now, the magnitude of these storms are absolutely massive. And second to none, is probably one of the biggest, it can turn out as one of the biggest natural disasters that can happen to a country if we do not take the necessary precautionary measures. Now, before I'm going to continue, what we need to do to look after ourselves during one of these storms, how do we identify a storm like this? And obviously, what we discussed in a couple of lessons earlier, we look at synoptic charts. Now, first of all, when do we experience tropical cyclones? We already discussed it. Late summer. Now, as you can see, quickly look at this data over here. It's in February. And another clue that you will have over here, look at it on the east coast of continents. Why on the east coast of continents? What do we experience? Warm ocean currents. Now, as you can see, the tropical cyclone forms between 5 degrees is up there. There's the 30 degrees latitude line. And the system moves in the westerly wind belt. After the break, we will continue with tropical cyclones on synoptic charts.